Hello students, today we are going to discuss another concept in the chapter thermodynamics part first. The concept is work done in isothermal reversible process. Before we get started in detail studying this concept, let us focus on the terms which are used in this concept. The first is work, isothermal, reversible and process. Though we have studied these terms in the previous few classes, let us rewind it again in a brief. The first term which is used in this concept is work. As we know that work is the one of the mode of transfer of energy between system and surrounding. The energy transfer takes place between system and surrounding as a result of work. That is the concept of work, or we can say work is done when some amount of energy in a particular form is transferred to the another form, that is the work. Okay, the next term used in this concept is isothermal process. In the types of process part, we have discussed what is mean by isothermal process. The process in which the temperature of the system remains constant throughout the process, that process is said to be isothermal process. Means throughout the process the temperature of the system is going to be constant. Such processes are called isothermal processes. And the last term which is used in this concept is reversible process. Reversible process. Types of processes, two types of processes, reversible process and irreversible process. The process which can be reversed is termed as reversible process. Let us take an example. Suppose a reaction A plus B gives rise to C plus D. Okay, let us consider before starting the reaction there will be no product, but as soon as the A reacts with B and forms the products molecule C and D, but here C also get reacted with D and forms the reactant molecules A and B. In such cases, when the product molecules in the forward reaction, these are the product molecules in the forward reaction and these are the product molecules in the backward reaction. Basically in the forward reaction, A and B are the reactant and C and D are the product. But the reaction in which whatever the product molecules are formed, they also react with each other and get converted back into A and B. Such types of processes are called reversible processes, which can take place in forward direction as well as in backward direction. Means the reaction can be reversed. Such process or reactions are called reversible reactions or reversible processes. But in case of suppose S reacts with T and gives rise to X and Y, but here X and Y do not react with each other, so there will be no problem of converting this X and Y into S and T. Since X and Y do not have any kind of reaction, they cannot react with each other, therefore they will not form S and T. Such reactions are called irreversible. They can proceed only in one direction but cannot be reversed. That is why such reactions are called irreversible. And the process in which product molecules reacts among themselves and converted into reactant molecules back, therefore such reactions are called reversible reaction. And by hoping you have understood each term work done, isothermal and reversible process. Let us proceed further to discuss the concept in detail. Okay? To understand this concept thoroughly, let us consider the gas is enclosed in a cylinder. The gas is enclosed in a cylinder which is fitted with, this is a piston. The gas is enclosed in a cylinder which is fitted with the wetless and frictionless. Why I am using the wetless piston? Because we are going to determine the work done by the gas as a result of expansion of the gas or compression of the gas, or the work is determined as a result of change in volume of the gas. Therefore, when we say the change in volume, when the gas expands, its volume is increased, and when gas compresses, the volume of the gas decreases. Means we are determining the work done by the gas in terms of change in volume. To increase the volume, the gas utilizes its own energy, but that energy should not be utilized to push the piston which is having some certain weight. If it has certain weight, then gas utilizes more energy to do the work, and that is why we will not be able to determine the work done during this expansion accurately. That is why the piston must be wetless. Okay? To understand this concept, the gas is filled in a cylinder which is fitted with the wetless and frictionless. Friction between the walls of the container and the surface of this piston. There will be no friction. We have to take care of that. And in such a cylinder, when this gas is having the pressure Pi and the pressure of surrounding, let us consider it as a P external pressure of the surrounding. Okay, since it is a reversible process, that means the internal pressure of the gas, that is system, and external pressure, that is the pressure of surrounding, if the difference between them is very negligible, the difference is infinitesimally small, that is very small difference is present in the pressure of internal gas and external surrounding. Okay, in such a position, when the internal pressure of the gas is infinitesimally greater than the external pressure of the gas, at that time the gas will expand to a small volume. Okay, when this is slightly greater, not too much, but when this is slightly greater than the external pressure, the gas will expand to a small amount. Okay, at the next moment, when the external pressure is slightly greater than the internal pressure, at that time again the gas will compress. Means in both direction. In this reversible process, the process takes place in both direction, expansion, compression, and let us assume in this process the gas is filled in a cylinder having the pressure Pi and against the pressure of external pressure P1. Okay, in this way the gas expands slowly and steadily in number of steps, in n number of steps, and gas expands to the volume of V2 from volume V1. It is not suddenly expanded, since the difference between internal pressure and external pressure is very small. That is why stepwise the gas expands to the volume of V2. V2 is the final volume of the gas and V1 is the initial volume of gas. Okay, now in the previous concept we have determined the work delta dW is equal to P into delta V. Okay, this is the work done in one step, that is work done in irreversible process. In the previous lecture we have determined this equation, okay, in one step process. Now I have not written here the symbol because if the work is done as a result of expansion of the gas, that means work is done by the system and that is always taken as a negative. Okay, and if the work is obtained as a result of compression of the gas, that indicates the work is done on the system and that always taken as positive. Always taken as positive means during the expansion work is negative, during the compression work is positive. Okay, now since we have not defined here whether it is an expansion or compression process, let us define this process as a expansion. Okay, we are determining the work done in isothermal reversible expansion of the gas. Now since it is a work done in one step or one step process, and as we know that this is a reversible process and it is taking place n number of steps. Okay, the work done in this step is given as this, then the work done in n number of steps can be obtained by integrating this equation. Okay, when we integrate this equation, it is the work done in one step, and suppose this process undergone n number of steps, then work done in n number of steps can be obtained by integrating this equation. Then we get integration of delta W, that is the work done in irreversible process, integration of P delta V from V1 to V2. Okay, now however we know that ideal gas equation, PV is equal to nRT, where P is the pressure of the gas, V is the volume of a gas, N is the number of moles of gas. How much quantity of gas is taken is expressed in terms of number of moles, where R is the gas constant and T is the temperature of the gas, which is going to be constant since the process is isothermal. This equation we can write it as P is equal to nRT upon V. Okay, we can simplify this equation in this form. Now put the value of this P in equation this, that is integration of work done in reversible process is equal to integration of, since it is a work done in expansion type of work, we can take it as a negative sign. Okay, now after putting the value of P in this equation, what we will get? nRT into delta V upon V. Okay, the integration we have taken from V1 to V2. Then after simplifying this equation, we get the value, that is W is equal to IW. This is the work done in n number of steps, W2 minus W1. We get W is equal to, here since n is a constant value, R is a constant value, and temperature is also a constant since the process is isothermal. We can take these three terms out of this integration since they are not going to change throughout the process. Therefore, minus nRT minus, is it what? Okay, I will write it in minus nRT, the integration of dV upon V from volume V1 to V2. Okay, we know the integration of this we will get, after integrating this equation, we will get minus nRT natural log V2 minus V1, V2 upon V1. Again, after simplifying, this is a natural log, conversion of natural log into simple log, that is log to the base 10 is written as 2.303 into 2.303. Then we get the equation W is equal to, by putting the value of this natural log, by simplifying this natural log to simple log, minus now 2.303 nRT log of V2 upon V1. nRT log V2 upon V1. This is the work done in isothermal reversible expansion. Isothermal reversible expansion. As we know that by applying the gaseous laws, P1 is equal to, P1 V1 multiplication of pressure and volume of a particular gas is equal to its P2 V2 multiplication of the pressure and volume of the gas in the final state is always equal. Therefore, this equation can also be written as V2 upon V1 is equal to P1 upon P2. If we put the value of this V2 in this equation, then we get W is equal to minus 2.303 nRT log of P1 upon P2. This is another equation for the maximum work done in isothermal reversible expansion. Since it is expansion, hence the sign negative. Okay. Here, these are the two equations with the help of which we can determine the work done in isothermal reversible expansion. If the work or the process is of compression, then this negative sign will be changed to positive sign. Okay. Now, the point to be noted here that remember one thing always, the work done in reversible process is always greater than the work done in irreversible process. Why? Let me explain it. Let me rub first a part of this board. Okay. Why? I used to tell the simple example to understand why the work done in reversible process is greater than irreversible. Reversible process means two-way process that can be reversed, means that process takes place in both directions. Suppose, and why this taking place in a reversible direction? Since the driving force and opposing force, the difference between them is very small. Sometimes the process takes place in forward direction and sometimes it may take place in backward direction. And why it produces more work? Okay, let us take an example of when, if I call the two students are having the same strength, okay, and they are asked to push each other in opposite direction. Okay. Now, if the two students or two boys or two students are having the same strength, then what will happen? They require a lot of energy to push back to the other person. Okay, means it has to expend more amount of energy to push that person, opposite person in the backward direction up to some distance. Or he or she requires more energy since they are having the same state. In the similar way, in the reversible process, both opposing force and driving force of the reaction, they are almost equal with the infinitesimally small difference. That is why to perform the work in a reversible process, it requires more energy. More energy means more amount of work is obtained during the reversible process. And again, let me write here these two equations because we are going to solve some numerical problems based on this concept, work done in isothermal reversible process. And to solve such problems based on this concept, we require these two equations. W is equal to that also W max, that is maximum work done obtained in the isothermal reversible process, negative 2.303 nRT log of V2 upon V1 we can solve. If in the numerical problem the change in volume is given, then we can use this formula, or if in the numerical problem whether the expansion or compression is expressed in terms of pressure, then this is the formula which can be used to solve the numerical problem. 2.303 nRT log of P1 and P1 upon P2. Why V2 upon? Because in the expansion volume increases, V2 is the volume in the final state, but in the compression volume decreases. But if we express the expansion of gas in terms of volume is increased. As the volume increased, pressure of the gas obviously decreases. Why? Boyle's law or the gaseous law says that volume and pressure are inversely proportional to each other. That is, if the volume of the gas increases, obviously its pressure would be decreases, and vice versa. Okay, I hope you have understood this concept thoroughly.